All right, this is this is homework number 8, the practice problems, solving trig, uh, solving trig expressions, equations, things like that. Let's go ahead and jump in because this can be challenging. So let's go. Number 1. So simplify secant x over cosecant x. Okay, one of the tricks or tips for solving this, well, there are two that I would suggest. Number 1, have your formula sheet with all your formulas and identities there. Number 2 is when you're actually working it out, change everything, all the quotients into uh, terms of sine and cosine. That always helps. So for this one, 1 over cosine x over 1 over sine of x. Okay, so for the steps for the people who may not like fractions, this is 1 over cosine x divided by 1 over sine x. Multiply by the reciprocal, or keep change or keep change flip. 1 over cosine x times, and then you flip the reciprocal. Sine x over 1, which is sine x over cosine x, which is tangent of x. Okay. I'm going to try not to move too fast, but I have to admit, this topic is where I really fell in love with math. Like, this is it. Logarithms, I kind of started liking it. This is where I really fell in love with it. Okay. So let's go ahead and move on. So complete the proof of the identity by choosing the rule that justifies each step. Now, to be honest, on the test, you may see something like this to talk about the rules. Those will be in your formula sheets. Most of the time, you're just solving, but let's do it. All right, let's number the steps. 1, 2, 3. A student actually suggested I do that. It's helpful. So to go from the initial problem to the first step, I'm changing 1 minus cosine squared x to sine squared of x. That is the Pythagorean identity. Pythagorean identity. Next, I change cotangent of x into cosine of x divided by sine of x. That is one of the quotient identities. And to multiply, to go from step 2 to step 3, sine of squared of x, there are 2 sine x's in the numerator over here. There's one in the denominator. I cancel it, or I reduce, and I'm left with sine x times cosine x, and that is just algebra. So this problem is done. Pretty straightforward, not that exciting. Not as much as number 3, which I am looking forward to. So let's do that. Whenever you're doing a problem like this, left hand, right hand of the equal sign, the goal is to make whatever side you start with look like the other side. Many times very much easier said than done. You want to, so whatever side you pick, you want to make sure that it looks like the other side. So let's start with the left-hand side because there's more to work with. So I'm going to rewrite the problem up here. I'm going to rewrite the problem up here so you can see it, so I can have a little space. So secant squared x minus 1 times cosine x. All right, that's going to be equal to secant squared x minus 1 is a property. Okay, it's one of those Pythagorean properties. This is equal to tangent of x, or tangent squared x, times cosine squared x. Oh, they made this problem super easy for us. All right, cosine tangent squared is cosine squared, not cosine. Tangent squared x is sine squared x divided by cosine squared x. And we are multiplying by cosine squared x here. Right. Denominator, numerator, both become 1. So I get sine squared x times 1 over 1, which is just sine squared x. Now, sometimes in math, when you're doing proofs, they'll make this little box with a little thing in it. That means we're done. In your textbook, whatever, it could have that. Sometimes it'll have QED, which stands for something in Latin, but it all means I'm finished. Okay, number 3. That's number 3. Number 4, prove the identity. A little more challenging. We can do the left-hand side or the right-hand side. I'm going to pick the left-hand side this time. If you're interested, let me know, and I will write out the right-hand side for you and post that. Okay, so we'll start here. We have secant x minus cosine x. Okay. That's my hand. Okay, I just saw a little thing over there. Didn't know what that was. All right, this is equal to 1 over cosine x minus cosine x. And we are going to multiply this cosine x by cosine x over cosine x, because we wanted to have the same denominator so we can add them. This becomes 1 over cosine x minus cosine squared x over cosine x. Cosine x times cosine x is cosine squared x. Okay, this is a pretty standard procedure of ways to do this type of problem, a problem like this. This becomes 1 minus cosine squared x over cosine x. Because they're the same denominator, you can put the fraction together. Okay, there it is. I got lost. Okay, this becomes Pythagorean identity, sine squared x over cosine x. Almost done. Some of you already see it. Is equal to sine squared x is sine x times sine x, and one of them is over cosine x. We'll pick this one. And sine x over cosine x, sine x times tangent of x. And we're done. Because now we match it with the right hand side. Wasn't that fun? I really enjoyed it. I really enjoyed doing these. Okay. I was working out one with a student and I got stuck. And that was just great. Love it. Because you have to think, you have to think about it, you have to figure out problems, many applications to real life. But let's go. Prove the identity. Sine x over 1 minus cosine x is equal to cosecant x plus cotangent x. There are a couple of different ways that you can do this problem. All right, both of the ways are kind of challenging, if I'm honest with you. Okay, but we're going to pick the lesser of the challenging ways to do it. So let's go. So I have cosecant x plus cotangent x. This is equal to 1 over sine of x plus cosine of x over sine of x. Same denominators, put them together. 1 plus cosine x all over sine of x. Now, a hint that I'll give you that I was never told. If you look here at where we're going, you have a 1 minus cosine x here. Okay, this is similar to or this is puts you in the mind of 1 minus cosine squared x, which is sine x. That's one of those Pythagorean guys. Okay, so a couple of different ways that we can get there. I'm going to pick the easier of the two. I'm going to multiply by the conjugate of the numerator, and I get multiply 1 minus cosine x over 1 minus cosine x. When we multiply this, we get 1 plus cosine x times 1 minus cosine x over sine of x times 1 minus cosine of x. So you may be saying, well, what good did that do? Well, these two multiplied together, these are called a difference of squares. Property, I'll write it in green for money. A plus B times A minus B is equal to A squared minus B squared. So in this case, we get 1 squared, which is 1, minus cosine squared of x over sine of x times 1 minus cosine of x. So before, when we were here, you were like, well, if we cancel this, we end up with what we started with. We don't cancel until we get to where we want to get to. Until we're making progress. That would be going backwards. So then we use the Pythagorean identity, and we get 1 minus cosine squared x is equal to sine squared x over sine of x times 1 minus cosine of x. Oh, well, this looks very, very close to what we want, doesn't it? I have a sine squared on the top, which is sine x times sine x, and a sine x on the bottom, so I can cancel, and I'm left with sine of x over 1 minus cosine of x, which is what I wanted. You can't tell me that wasn't fun. How do I know all this? I just know it. But to be honest, not to be funny, the only way to learn this is by doing it and doing it multiple times. It's the only way to learn how to do it. I know this well because I've handled it a lot. And I mean, it's kind of also because of the way that I think. Not that I'm so special minded or anything, but math, I look for connections and things, and this is what this is. You're looking for how things connect and what properties can we use and stuff. Okay. So let's move on. I got into my area a little bit. So let's see if I can do this. And not get off the screen. All right, so we have secant of negative x minus sine of negative x times tangent of negative x is equal to cosine of x. Let's work it out. So secant of x, negative x, is, yeah, why not? Secant of negative x is, let's do it, 1 over cosine of negative x minus sine of negative x times tangent of negative x. Here's where your cheat sheet will help you. We're picking the left-hand side, obviously, to work on. Cosine of negative x is the same as cosine of x. Minus sine of negative x is negative sine of x. Whoops. And negative tangent of negative x, tangent acts like sine. So that is negative tangent of x. Okay, I'm gonna write a space here, so. Okay. So tangent, negative tangent we know is negative sine of x over cosine of x. All right, so we have equal to 1 over cosine x minus the negatives for these two cancel out. Boom, boom. So I get minus sine of x times sine of x over cosine of x. This is 1 over cosine of x minus sine squared of x over cosine of x. Some of you see it. Go down so you can see that. 1 minus sine squared of x over cosine of x. Pythagorean identity, this becomes cosine squared of x over cosine of x. 2 cosine, because there are two cosines on the top, one on the bottom, and I'm just left with a cosine of x. Boom. Again, I don't know about you. I'm having fun with this. I'm not saying that we sit around the house and do math problems, but when we get off of this, and posting this, there are some other, like there's a math problem that I'm working on to try to figure out. Something went wrong and I'm trying to figure out what that was. So yeah. All right, so find the exact value of cosine of 75 by using a sum or difference formula. Go to your formula sheet and you see cosines. Cosine of, where is it at? Right. No, not that one. There are two formula sheets that I'm going to send to you. Well, I'm going to potentially post if I'm asked. I don't want that one, so I'll do this one. Here we go. Sine of x plus y, sine of x minus y, cosine of x plus y, cosine of x minus y. So we want to know, we need two numbers to add up to 75. Now, within a unit circle, you can use any of those numbers that add or subtract to 75. I'm going to show you the easiest one. Cosine, or one of the easiest ones. Cosine of 75 is equal to cosine of 30 degrees plus 45 degrees. Okay, so cosine of 30 plus 45, x plus y, or a plus b, whatever your formula sheet has. Again, if you need one, let me know. But this is cosine of 30 degrees, cosine of 45 degrees, minus sine of 30 degrees, sine of 45 degrees. I hope that this is not too small. If it is, somebody let me know. Okay, so that is cosine of 30 degrees is root 3 over 2. Cosine of 45 is root 2 over 2. Minus sine of 30 degrees is 1/2. Sine of 45 is root 2 over 2. So this becomes root 3 times root 2 is root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 over 4. Boom. Yeah. All right. Use a sum or difference formula to find the exact value of the following. So you see here we have cosine something else, plus sine something else. So this is cosine x, cosine y, plus sine x, sine y. Look at your formula sheet, and you see that this pattern is formed by cosine of x plus y. Nope, cosine of x minus y, because the cosine minus there becomes plus there. So this becomes cosine of 17 pi over 18 minus pi over 9. Do a little fraction, mathy math. Get cosine of 17 pi over 18 minus 2 pi over 18, which becomes cosine of 15 pi over 18. That's done on the unit circle. But if we reduce it, it becomes cosine of, make sure y'all can see that. Yeah, this becomes, hold on, I got a solution. There we go. This becomes cosine of, if we reduce that, divide both by 3, you get cosine of 5 pi over 6. That's on the unit circle. We know that. That is negative root 3 over 2. All right, last problem. Use the information given below to find the cosine of alpha plus beta, Greek numbers, or Greek letters. Tangent of alpha is 5 over 12 with alpha in quadrant 1. Boom, boom. Alpha and tangent of alpha is 5 over 12. Then beta, cosine of beta, beta is in quadrant 4. And cosine of beta is 12, so same 12 over 13, which is the, so this is beta, and that is 13. Okay, if you know your Pythagorean triples, then you automatically know that that's 13 and that's 5. You automatically know it. But in case you don't, for the bottom one, 12 squared plus 5 squared is equal to hypotenuse squared, where 12 is one side and 5 is the other side. Well, the legs, one leg and the other leg. This is 144 plus 25 is equal to h squared. This is 169 equal to h squared. And if you take the square root of both of those, you get 13 is equal to h. And the bottom one follows the same pattern. So, cosine of alpha plus beta, we just did this, is equal to cosine of alpha cosine of beta minus sine of alpha sine of beta. Cosine of alpha is 12 over 13. Cosine of beta is 12 over 13. We just said that. Minus sine of alpha is 5 over 13. Sine of beta is 5 over 13. Actually, it's like negative 5 over 13. It's supposed to be. So actually, we'll do negative 5 over 13. We'll do it right. All right, the hypotenuse in these, the hypotenuse is always positive. This 12 is always positive. 5 is positive here, negative there. That's why 5 is negative there. Sine of beta is negative. Okay, so this becomes 12 times 12 is 144 over 169. You have negative 25, so minus negative 25 is plus 25 over 169. Well, above we already showed that 144 plus 25 is 169. So this is 169 over 169, which is equal to 1. Boom. When in doubt, draw a picture. Okay, and have your formula sheet handy. You're going to need it. All right, any questions on this, definitely ask them. Let me know. But this concludes homework number 8 video.